Assalamu alaikum. This is Muhammad Mahid Khan Amir, lecturer in mathematics, EMDS, Rajaguttura Model College. Today our class is on general mathematics for class 9 and 10. Like our previous class, our today's class also on exponent. In our previous class, we have discussed about the logic, the laws of exponents and some definitions like zero index and negative index, and obviously the nth root that was like fractional index. So, and we have started the chapter 4.1. We have done two maths. Today we will also doing the maths from chapter 4.1. First math we will do is number 6. The question is simplify root over x inverse y into root over y inverse z into z inverse x. So to solve this math, we will have to write the given line in our first line, that is in our solution part. Then we know x inverse y is equals to x inverse something power negative means 1 by that term, that is x inverse means 1 by x. We have given the formula why this can be written like this here: a to the power minus n equals to 1 by a to the power n. Exactly, this is not a formula, but from the definition of negative index we have learned this formula. So applying that, we will get, for the term root over x inverse y, we will get 1 by x into y, and for y inverse z we will have 1 by y into z, and for z inverse x we will have 1 by z into x. So here we know very well how to do multiplication. So 1 by x into y, that is y by x, as we cannot cancel anything. So our next line will be root over y by z into root over z by y into root over x by y. In our last class, we have learned a formula of power of powers, that was like, or power of multiplication. In power of multiplication, the formula was it a into b whole power n equals to an into bn. The exact formula was like an into bn, exactly a to the power n into b to the power n is equals to ab whole power n. So just reversing that formula, we can write root over x by y into z by y into x by y, following the formula a to the power n into b to the power n is equals to ab whole to the power n. Here in every term, y by x, z by y, and x by z is power half, that is root over. So we can write it in this way: root over y by x into z by y into x by z. Here we can see this y can be cancelled by this y, this z can be cancelled by this z, and x will be cancelled by this x. So we will get root over 1. So we know root over 1 is equals to 1. So the solution of this math is 1. Giving you a minute to write it down, or giving a time to understand actually. Next math is number 8. Here the problem is simplify 3 to the power m plus 1 divided by 3 to the power m whole power m minus 1 divided by 9 to the power m plus 1 is also divided by 3 to the power m minus 1 whole to the power m plus 1. So to simplifying this math, the solution will be, solution equals to, or solution is 3 to the power m plus 1 divided by 3 to the power m whole to the power m minus 1 divided by 9 to the power m plus 1 divided by 3 into m minus 1 to the power m plus 1. So here we can see in our first term, or in our first part, we have got the same base 3 and 3, and in our second part we have got in numerator the base is 9 and denominator the base is 3, but we can reshape the base of numerator of second term, that is 9 can be written as 3 square. So we will do that in our next line, and we have learned a formula: a to the power n to the power n equals to a to the power m into n, that is a to the power m into n. The powers will be multiplied. So applying that formula in the denominator of first part, we will have 3 to the power m plus 1 divided by 3 to the power m into m minus 1. And in the second part, as I have said, 9 can be written as 3 square, so 3 square whole power m plus 1, or to the power m plus 1. And in denominator, applying the same formula, I to the power m to the power n is equals to a to the power mn. So that is like 3 into, sorry 3 to the power m minus 1 into m plus 1. In the first part, we can see that we have a division of two terms with same base, so we can write 3 to the power of numerator minus the power of denominator, or just multiplying the lines actually here. So 3 into simplifying the, or multiplying the powers. So 3 to the power m plus 1 divided by 3 to the power m square minus m divided by 3 to the power here. Applying the same formula, a to the power m to the power n is equals to a to the power mn. So 3 to the power 2 into m plus 1 divided by 3 to the power m square minus 1. Here there is a formula, a plus b into a minus b equals to a square minus b square. So applying the formula, we will get 3 square 3 to the power 2 into m plus 1 divided by 3 to the power m square minus 1. So in our next line, as I said in the previous line, the base is same and there is a division in between them, so there will be minus in the powers. So 3 to the power m plus 1 minus m square plus 1 divided by 3 to the power 2m plus 2 minus m square plus 1. The formula is a to the power m divided by a to the power n is equals to a to the power m minus n. We have to do the calculations. If there is any cancellation or any plus or minus, we have to do that. Here in our first part, 3 to the power m plus 1 minus m square plus 1. So m and m can be added. So adding them, we will have something like 3 to the power 2m plus 1 minus m square divided by 3 to the power 2m plus 3 minus m square. The next line, here again we have the same, we have to apply the same formula of division, because here we got a division sign and in the two parts of the division sign we got the same base 2, so the powers will be minus. So here 3 to the power 2m plus 1 minus m square, as in the last term there was 2m, so subtracting it we will have minus 2m, and plus 3 will be replaced by minus 3, and minus m square will be plus m square, because we know if we multiply something with minus 1 or with minus, the signs will change. So from that, 2m has become minus 2m, 3 has become minus 3, and minus m square has become plus m square. Now we have to do the calculation, plus or minus. Look at here, 2m will be cancelled by 2m, minus m square will be cancelled by m square. So 3 minus 1 minus 3 is equals to minus 2. So finally we will have 3 to the power minus 2. You can put the answer here, but this is not the simplex form, as the problem is to simplify. So we can write some lines like a to the power minus n is equals to 1 by a to the power n. So from there, 3 to the power minus 2 will be equal to 1 by 3 square, and we know 3 square is equals to 9, so the solution will be 1 by 9. To do well in this chapter, the main factors are to understand what is our base and what is our power, and then the formulas, the 7 formulas we have in this chapter. Exactly 8 formulas, 5 are real formulas and 3 became formulas from the definitions. Moving forward, our next math is number 9. We have to prove 4 to the power n minus 1 divided by 2 to the power n minus 1 is equals to 2n plus 1. So in the solution part, we will start from the left hand side, that is equals to 4 to the power n minus 1 divided by 2 to the power n minus 1. Here we have a base 2 in the denominator and a base 4 in the numerator, though we have a part minus 1 in both the terms. Other than that, the exponent term or the power term is in the first part of both denominator and numerator. So we can change 4 into 2 square, or we can change the base 4 into 2. So doing that, 4 can be written as 2 square, so 2 square all to the power n minus 1 divided by 2 to the power n minus 1. So here we can apply the formula of power of the powers, that was a to the power m to the power whole n is equals to a to the power m n. Then we can reverse the formula once again, so we can write like a to the power n to the power m. So from there we can write it like 2 to the power n whole square minus 1 divided by 2 to the power n minus 1. I have given a side note that that is what I said, a to the power m to the power n is equals to a to the power m n is equals to a to the power n to the power m. Just reversing the facts, reversing the power actually, swapping the position of the power. So here a square minus 1, we know the formula, a square minus b square is equals to a plus b into a minus b. Maybe the most used formula in algebra. So 2 to the power n plus 1 into 2 to the power n minus 1 divided by 2n 2 to the power n minus 1. Nothing is changed in our denominator part. So now we can cancel 2 to the power n minus 1 in the numerator with 2 to the power minus 1 in denominator. So cancelling them, we will have 2 to the power n plus 1. This is our right hand side. So our problem is proved. Giving you 1 minute to write it or relook it. Okay. Number 12. Prove that a to the power p plus q divided by a to the power 2r into a to the power q plus r divided by a to the power 2p into a to the power r plus p divided by a to the power 2q is equals to 1. Here also we have to start from the left hand side. The left hand side equals to a to the power p plus q divided by a to the power 2r into a to the power q plus r divided by a to the power 2p into a to the power r plus p divided by a to the power 2q. So here we have three parts in this math. So look at every part. In all the three parts we got the same base a in both denominator and numerator, so we can say, or we can apply the formula of a to the power m divided by a to the power n, which is equals to a to the power m minus n in all the three parts. So applying that formula, we will have a to the power p plus q minus 2r into a to the power q plus r minus 2p into a to the power r plus p minus 2q. Here the formula we have applied is given in the side note, that is a to the power m divided by a to the power n is equals to a to the power m minus n. As there can be no calculation done in the powers of each terms, so we can apply the next formula. As we have the same base in in all the three terms, and there is multiplication sign in between them, so we can apply the formula of or index law of multiplication, or multiplication law of index, that is a to the power m into a to the power n is equals to a to the power m plus n. As we have three terms, so three powers will be added, that is a to the power p plus q minus 2r plus q plus r minus 2p plus r plus p minus 2p. If we add them, so here we have 2p's, then minus p minus 2p, so p's are cancelled, then q plus q minus 2q, q's are also cancelled, then the last term we have left is r minus 2r plus r plus r, so all the r's are also cancelled. So we all we have is a 0, that is a to the power 0, and we know if a is not equals to 0, then a to the power 0 is equals to 1. So from that law, a to the power 0 is equals to 1, so which is equals to our right hand side. So this is our solution of number 12. I am repeating myself. All you need to do to complete this chapter is to memorize the formulas well and try to understand which one is our base and which one is our power. That's all for this chapter. Next math, number 15. Prove p to the power, sorry, x to the power p divided by x to the power q whole to the power a p plus q minus r into x to the power q divided by x to the power r whole to the power q plus r minus p into x to the power r divided by x to the power p whole to the power r plus p minus q is equals to 1. Again, as we have to prove it, we will start from the left hand side, that is solution. Left hand side equals x to the power p divided by x to the power q whole to the power p plus q minus r, x to the power q divided by x to the power r whole to the power q plus r minus p, x to the power r divided by x to the power p whole to the power p plus, sorry, r plus p minus q. Here in we have got three terms like the previous math, and all the terms there is a division and there is given a whole power of the given division. So first of all, we have to apply the index law of division, which was like a to the power m divided by a to the power n is equals to a to the power m minus n. So applying that formula, as we have got x in as base in the numerator and denominator in all the three terms, so we can apply that formula. Applying the formula, we will have x to the power p minus q whole to the power p plus q minus r. For the second term, x to the power q minus r whole to the power q plus r minus p. And for the last term, actually last part, these are not terms, there is only one term in this math, x to the power r minus p to the power r plus p minus q, and the formula we have applied is a to the power m divided by a to the power n is equals to a to the power m minus n. So next line we can easily see that next line will be we have to apply the formula of power of powers, which was like a to the power m to the power n is equals to a to the power mn. So applying that formula, x to the power p minus q into p plus q minus r. For second term, x to the power q minus r into q plus r minus p, x to the power r minus p into r plus p minus q. Now we have to simplify the terms in the powers. So we have to multiply the terms. So multiplying them, for the first term, we will have x to the power p square plus pq minus pr minus pq minus q square plus qr. We have to apply, we have to multiply p plus q minus r with once with p and again with minus q. For the second term, we have to multiply q plus r minus p with q and again q plus r minus p with minus r. So multiplying that, we will have x to the power q square plus qr minus pq minus qr minus r square minus pr. And for the third term, multiplying r plus p minus q with r, we will have r square plus pr minus qr, and lastly multiplying r plus p minus q with minus p, we will have minus pr minus p square plus pq. Now we can again do some addition or subtraction in the power terms. So cancelling them, we will have x to the power p square minus pr minus q square plus qr. For the second term, plus qr and minus qr will be cancelled. We will have x to the power q square minus pq minus r square plus r plus pr. And in our last term, our last part exactly, the term plus pr and the term minus pr will be cancelled. So we will have x to the power r square minus qr minus p square plus pq. Now we got three parts, all have, or exactly they have two multiplication in between them and they have the same base x. So we can apply the formula of a to the power m into a to the power n, which is equals to a to the power m plus n. So applying the formula, we will have x to the power p square minus pr minus q square plus qr plus q square minus pq minus r square plus pr, then plus r square minus qr minus p square plus pq. I have written the formula in the side note. You should give the side notes. Now do the calculation in the power term. Start from p square. So here p square can be cancelled with the second last term minus p square, minus pr can be cancelled with plus pr, which is in between 2r square. Then minus q square is cancelled with plus q square, minus plus qr is cancelled with the third last term minus qr, plus q square can be cancelled with minus q square. I have said that. Then minus pq can be cancelled with plus pq, which is the last term. Then minus r square can be cancelled by plus r square. So we can see that all terms are cancelled by each other or their additive inverse term. So all we have is x to the power 0. Here x is not given 0. So as x is not equals to 0, we can say that x to the power 0 equals to 1. Why I am saying that? Because in the formula or in the definition of zero index, we have said that, or we have learned that a to the power 0 will be equals to 1 if and only if a is not equals to 0, because 0 can be multiplied 0 terms, this kind of things. So we got 1, which is equals to our right hand side. So that's how we have proved the problem. Number 16, if the problem is if a to the power x equals to b, b to the power y equals to c, and c to the power z equals to a, then show that x, y, z is equals to 1. So to solve this math, we will start from c to the power z equals to a. Now look at the given terms. C is equals to b to the power y. So we can replace c by b to the power y. So or b to the power y to the power z is equals to a. Here b to the power y is equals to c. We got it from the problem. It is given. This is not any formula. Now we can see that b to the power y whole power z. So we can apply the formula of index law of powers. That was a to the power m to the power n equals to a to the power mn. I have given that in the side note. So applying that, we will have b to the power yz equals to a. Now again, if we look at the formula, or again if we look at the problem, we can see that the value of b is a to the power x. So we will replace b by a to the power x. Replacing that, we will get a to the power x to the power yz is equals to a. Cos a to the power x equals to b, which is given. Then again, like previous line, the formula of powers of index, which is a to the power m to the power n equals to mn. Applying that, we will have a to the power x, y, and z. And as there is no power in the right side of the equation of a, so we can give a 1 as power. So a to the power x, y, z equals to a to the power 1. Now we will face a new thing here. This is not a formula, or this is a formula which came from the definition. Suppose we have two terms in the equation of two sides, then obviously they are equal, otherwise we cannot use the equal sign. Now if we have one side 2 to the power 1, in other side we must 2 to the power 1 is equals to 1. So we cannot have 2 equals to 4 or 2 equals to 8 or 2 equals to 16. They cannot be equal. So as if the base is same, that is 2 in left side and 2 is right side, there to be equal, their power should be equal. So from that sense, we can say that a to the power xyz, or we can write a to the power xyz equals to a to the power 1 is like xyz equals to 1. So this is our solution. Our next math is number 17. Solve 2 to the power x plus 1 is equals to 128. This is the most easiest math of this chapter, or simplex math. So we know when we have got something to solve, we have to find out the value of the variable. Here our variable is x, so we have to find out the value of x. So starting solution, 2 to the power x plus 1 is equals to 128. We can simplify 128, we can write it 2 to the power 7. So or 2 to the power x plus 1 is equals to 2 to the power 7. Now, like the previous math, 2 to the power 7 must be equal to 2 to the power x plus 1 when x plus 1 will be equal to 7, otherwise they won't be equal. So from that hypothesis, x plus 1 is equals to 7, and changing the side of 1, it will become minus 1. So x equals to 7 minus 1, so x equals to 6. This is our required solution. So this is all for our today's class. Like before, as I said, if you have any problem, you can ask me in our classes, or you can knock me through my phone to clear your confusions. And as we are going through a pandemic, we all need to stay strong and stay safe. Thank you all.